Sirjan Kortta fibers. Let's talk about the role of the polymer fiber in preventing the expansion of cracks in concrete. Adding reinforcement to the concrete helps to absorb stresses and to limit the formation of cracks, increasing the load-bearing capacity and ductility of the concrete structure. There are several ways of reinforcing concrete. We've all heard about rebar, steel mesh and steel fiber. But did you know polymer fiber is just as strong and reliable? Since its introduction over 6 years ago, polymer fiber reinforcement has proven its merits in the most demanding structures and applications. Polymer fiber has no rust effect and is eco-friendly. The core difference between polymer fiber and other reinforcement solutions is that fibers are part of the concrete matrix, turning it into a composite material, instead of providing strength in distinct locations. Polymer fibers form a reinforcing network throughout the entire concrete structure, increasing its overall ductility. So how does this translate into concrete behavior? Take a random concrete structure. When subjected to loading, compressive and tension stresses start to build. Over time, small cracks will appear in places where the stress reaches critical point. Polymer fiber interacts within the concrete matrix, absorbing tensile stresses at any point and in any direction. As a result, polymer fiber picks up small cracks much faster than traditional reinforcement. When a crack occurs, the edges of fibers remain solidly anchored on each side of the crack, acting as a stress transfer media. Once the maximum bond strength with the concrete is reached, the pull-out takes full effect. This enables the next fiber takes over, delaying cracks from growing. Different loads require different polymer fibers. To meet any design requirement, Sirjan Nano-Yarn and Granule offers 3 polymer fiber types: Kortta Blend, Kortta Emboss, and Kortta Sinusoidal. Each fiber has its own feature, strength, modulus and ductility. Consequently, they also behave slightly differently when dealing with stresses. Let's take a closer look. First up is Kortta Blend. When a small crack occurs, the edges of Kortta Blend firmly anchored inside the concrete matrix. As the stress increases, the edges slowly deforms. As soon as the fiber loses its bond with the concrete, the pull-out takes full effect. Kortta Emboss provides the same process, but with even better anchorage and significantly higher tensile strength of 600 to 700 newtons, square millimeters or more. Kortta Sinusoidal behaves differently altogether. Here the edges never pull out from the concrete. As the stress increases, the fiber slowly elongates until it reaches its maximum strength. With a tensile strength of 700 to 850 newtons, square millimeters and elongation of 6%, concrete structures reinforced with Kortta Sinusoidal can take high flexural stresses over a long period. Based on these behaviors, we can conclude that Kortta polymer fibers effectively increase the load-bearing capacity of concrete. It can be used in almost any concrete structure with or without additional reinforcement, where the ductility of your concrete structure depends on the length, diameter ratio of the fibers and the number of fibers used per cubic meter. It is essential that enough fibers overlap to create a continuous network in the concrete mix. Polymer fibers are added to the concrete at the mixing stage. And in addition to concreting, in the construction of concrete segments and shotcrete is also a good alternative to steel mesh. Do you need help finding the right fiber and determining the right dosage? Sirjan Nano-Yarn and Granule gladly provides expert guidance through each step of your project, from design to execution. Visit www.sirjannano.com.